here we go. All right, ladies and gentlemen, so our official learning objective is, write this down, welcome, welcome. What we're doing is a little bit of what we did yesterday, but we're just doing it in reverse, okay? So kind of the opposite of using the distributive property. Our official right here, we will solve quadratic equations by factoring, so that's a new word, with reverse distribution. Just in general, factoring is a huge topic, and you will definitely see that on your STAR exam coming up, okay? So we will solve quadratic equations by factoring with reverse distribution. Our definition for factoring is to express a polynomial as the product of monomials and polynomials. A lot of nomials there, okay? So let me give you a for example. Okay, you know how like yesterday we went from 3 times, like this is kind of like distribution, right? We did this business where we just say 3 times x, 3x, and we say 3 times 4, and then we have 12, okay? So this is my counter example because this is called distribution, right? So this is my counter example. Factoring is actually going from 3x plus 12 and knowing, hey, we can divide everything by a 3 and 3 times x. So I can say like, oh, okay, well, if I divide this by 3, I get x. So that's going to go there. And if I divide 12 by 3, I get 4. So it's kind of taking it in the reverse, starting here and then ending up here. Okay, that's factoring. We will get to factoring by grouping, and that's something where we use the use of the distributive property to factor some polynomials having 4 or more terms. Okay. Go ahead and pause that real quick. So my, for example, would be something like this, where we have like x plus 3x, and then we have maybe 2 plus 9, okay? And so here we're kind of going to group based on things that have in common. So these two terms have an x in column in common, if I can speak. And then these two are constants, right? And so we can kind of use that fact to then group and then factor, okay? So that's my example for that one. Last but not least, we have the zero product property. This will be super important. And the zero product property just states that anything multiplied by 0 is 0. So anything multiplied by 0 is 0. Okay. And so you could take 5 times 0, you get 0. X times 0 is 0. Okay. Thank you, sir. Or you could even, yeah, just basically anything. It doesn't even matter. 5 million. Okay. Times 0 is still 0. Now, if we divide, that's a whole nother thing. 5 divided by 0 actually does not exist, and it's considered undefined. We never, ever, ever divide by 0. That's my counter example right there. Okay. No, you can, yeah, it's fine. Just listen to the thing. All right, example 1A. Let's go ahead. Use the distributive property to factor 5x plus 25x squared. All right, so y'all were a box class, and I think most of my classes were boxes yesterday. I'm going to go ahead and draw a box for you guys. Let's see if I can. Okay, and inside the box, so like yesterday we put stuff outside, right? And then today we're going to put things inside, right? So we have that first term, 15x, and then we have the second term, plus 25x squared. Easy enough, right? And we're looking for what they both have in common, okay? So what's the biggest number that I can divide both 15 and 25 by evenly? 5, beautiful. And then what else do they have in common? An x, okay? And we want to look at the exponents because this is really x to the power of 1, right? And so we want to pull like the biggest number, the biggest exponent. So here we have the biggest number is just 1. So it's going to be 5x. Does this make sense? Okay. What times 5 will give me 15? Beautiful. And do I need to multiply by another x? I already have 1. So we're good, right? Does this kind of make sense? And if you need to think about it, you could always put it in reverse. If we were doing it like this, 5 times 3, you would get, could we order it? And then you get 15x. So we kind of did it in reverse, right? And then here, what number would go here? 5. And then I love that y'all knew it was another x because x times x is x squared, right? So ladies and gentlemen, our final answer is going to result in, we pull the multiplier up front, 5x. And then inside parentheses, we put our binomial, 3 plus 5x. One little thing that I don't imagine you would see it like this on a test. You probably would see it more like because they like to go in descending order, right? But either one of these will absolutely work. Any questions on this? No? Okay. All right, go ahead. Let's try. Here. I'm going to draw the box. Okay. And how many boxes do I need? Did you say 2? 3. Okay. All right, so we're going to drop those in. My boxes weren't quite big enough, but you got the idea. Okay. So, any ideas? How do we come up with the biggest number? I'm just going to share my, I start off with my smallest coefficient, 12. And I can actually list out the factors, right? I'm not going to, I've got 1 times 12, 2 times 6, and 3 times 4, right? And I start right here and I work my way around, okay? So can I divide everything here by 12 nice and evenly? I can do 6? I love that. So then that's what we're going to put here, 6. Okay, everything is divisible by 6. How about my x's? Does everybody have an x? Yes. And what is my smallest coefficient? I agree. It's 1. So I'm going to put x to the power of 1, okay? And then everybody has a y, right? And my smallest coefficient again is 1, okay? So I want y'all to go ahead. I'm going to give you a little time. I want you to figure out what goes on top, okay? Pause this. All right, so again, just because I forgot to unpause. Welcome back. We're looking at 12 divided by 6 is 2. 24 divided by 6 is 4. And negative 30 divided by 6 is negative 5. Now, when we divide, so when I divide x to the first power by x to the first power, what am I doing with my exponents? Subtracting. So 1 minus 1 is 0, and the whole thing is gone, right? It's like we already have an x, so we don't need another x. We already have a y, so we don't need a y. Does that make sense? Everybody okay with that? All right, so here I already have an x, right? 1 minus 1 is 0, it's gone. But here I have 2 minus 1, which is just 1, right? Again, here I have x to the second power minus 1, which leaves me with 1x, x to the 1 power, okay? And then y to the 4, so 4 minus 1, which is y to the power of 3. Do y'all kind of see that? I think a lot of people were super duper close. They just kind of messed up on a few. Okay. So what we're looking at right here is 6xy times 2 plus 4y minus 5xy to the third, close parenthesis. And for our purposes, we're going to leave it like that and call it a day. Any questions? All right. I thought y'all did pretty good. Well, let's look at the next one. Example 2. So this is what typically happens when we start getting at least 4 terms, right? We can actually regroup these and kind of look at who has what in common. So here are our 4 terms. And while I'm dividing them up, who do you think has the most in common with 2xy? Which term has the most in common? The second, the third, or the fourth term? The second term, y'all feel like they have the most in common? Okay, we could do it that way. Honestly, I don't know. I feel like negative 2y just because it's got a 2 and then they have a y, right? Oh, that's just me. Huh? Wouldn't it zero it out because negative 2y plus 2y? Oh, that's a good question. He said, wouldn't they cancel out? No, because they are not like terms. How come these are not like terms? They both have y, but they both don't have an x, right? So you won't cancel them out. They're not like terms, okay? So you could do that, but I'm looking at this and then, yeah. Okay, so let's go ahead. We can do it the way y'all said it. We could group it like that. You could have also grouped the 2x's and the 2y's. That's fine too. I'm going to go ahead and just rewrite this where I'm going to put my parentheses here. Actually, let me just go ahead and do it on the next line here. 2xy, since y'all feel like these two have the most in common. And then plus, and I got negative 2y minus 7. Okay. Now, if I'm looking at this one, let me go ahead and do my little box. What's going to happen is I'm going to make 2 factoring boxes here. Okay. And I'm going to drop all this in. So I got 2xy and 7x plus 7x. All right. So when I do my little factor, I look at 2, right? And I got 1 times 2, and that's about it, right? Can I divide everything by 2? No. So it looks like 1 is my winner, right? That's the biggest number. And then what else do they have in common? An x. Very good. So what's left to go on top here? 2 divided by 1 is 2. Do I need any more x's? No. And I still need a y, right? Okay, here we go. 7 divided by 1 is just 7. Do I need another x? No. So ladies and gentlemen, I'm going to drop the 1, and that's just going to become x times 2y plus 7. Y'all see that? Okay, now we're going to do it again. We're going to drop those in. Negative 2y minus 7. Okay? So hold on one second. What do you think we should put in the front? Because they don't share a y. What do they both share? A negative. Let's go ahead and make it a -1. So -2 divided by -1 is, and if you don't know, -2 divided by -1 is +2. And I still need a y, right? Again, -7 divided by -1 is 7 plus 7. So I'm going to rewrite this like this. And I want you to think about the next step to do this. So basically, it's kind of like I can draw a big, huge box around this, right? I wish I had more space, but okay. And I'm going to erase this really quick. And instead of drawing on the top, I'm going to put it on the bottom. But they both have a factor in common, right? They both have that 2x plus 7, the 2y plus 7, right? So I'm going to pull that out front, 2y plus 7 times x. Are you okay with what I did here? Does that make sense? X times 2y plus 7 equals that. And what do you think I would put right here? Yes, -1. And so what we end up with, I'm going to put parentheses around all that. Our final answer is 2y plus 7 times x minus 1. And this is our answer. So kind of getting a little bit more complicated, right? And this is called multiplying binomials, which is what we'll get into probably like Wednesday. Maybe a touch on Monday. Okay. All right. Example 3. Let's go ahead and look at this one. And you don't have to always keep them in order, just saying. Let's go ahead. I'm going to write it out. 15a minus 3ab. I'm going to group them. Plus 4b minus 20. I'll draw the box. 2 boxes. And this is really helpful for when you have like 4 different terms, but none of them have one single thing in common. Okay, so this can be helpful in that situation. All right. Let me see, I'll set up the boxes. If you're watching the video right now, this is a good time to pause. All right, so I'm just gonna go ahead and drop this in. I got the 4b minus the 20. Make sure you include those signs. 15a minus 3ab. So your multiplier, you got basically, I'm just going to go with 3 here. You got 1 times 3. That's it, right? This is divisible by 3. So I'm going to put it right up here. And they both have a to the power of 1. Here, no, both of them do not have the variable of b, but they both are divisible by 4. So I'm going to put plus 4 up here. Okay. Now I'm going to go ahead and divide. I end up with 5, with negative b, with b, and negative 5. Any questions? Okay. And we can kind of set it up like this, that this is 3a times 5 minus b plus 4 times b minus 5. Yes? By the way, what do you notice about 5 minus b and b minus 5? Are they the same? Yeah. Okay, so let me kind of show you, kind of a trick, okay? If instead of positive 4, I had made it negative 4, then this would have been what? Negative b, and this would have been positive 5, right? And then we would have had 5 minus b. Are y'all okay with this? And now it would have totally matched. Oops, not positive 4, but negative 4. So that's something, if you're kind of going through this process and it's not like everything looks good, but like the signs are off just a little bit, then you can kind of manipulate the multiplier a little bit, and then you kind of get totally the same in there, right? And so when we do that, I'm going to do my big box. Both of them have a factor of 5 minus b. And out comes the 3a. Here comes your -4. And we're going to write our final answer of 5 minus b times 3a minus 4. Any questions on this? All right. And let's see, how are we doing on time? 9:30. Okay. Let's go ahead and let's do these last two. Remember how I said anything times 0 is equal to 0, right? Okay. So if I wrote this, I have two things going on here, right? If I said, you know what, x minus 2 is going to equal 0, that would mean that 0, I'm going to replace this right here, times 4x minus 1 would equal 0. Would this be a true statement? Anything times 0 is 0. So this would be true, yes? Yes or no? Yeah, okay. Y'all see. If you don't, let me know. And then on the other end over here, what if I made 4x minus 1 equal to 0? So I'm basically replacing all of that. I got x minus 2 times 0 equaling 0, which is also a true statement for both of these, okay? So I got two choices. And this is the beauty, is that if you can make at least one of your factors equal to 0, the whole thing works, right? So if I have x minus 2 equal to 0, I'm going to solve for x. What's the one thing I have to do to get x all by itself? Add 2, thank you. This is an additive inverse. X equals 2. Easy enough? All right, over here, remember 4x minus 1, we just got to get that one equal to 0. This is going to be a two-step equation, and the first step I'm going to do is add 1, good. And then the second step that I do is, there you go, adding 1 to both sides, that zeroes out, and we divide by 4. And x will equal 1/4. Ladies and gentlemen, you actually have two solutions. And the way that we might write it is as a solution set. That's where we have curly brackets. And one solution is 1/4, and the other solution is 2. So for the first time, we're looking at solving equations that have more than one answer, and it's not just infinite, you know, all real numbers, that type of thing. Okay. Any questions? Okay. Now, before we can apply this method, and we look over here, notice how all of my variables were on one side, right? You have to always have it set equal to 0. So I'm going to write that here. Before solving, write the equation. So it is set or equal to 0, okay? Or else this doesn't work, because the whole idea is you got to have two things that multiply that give you 0, right? So I'm going to go ahead here, and I think I'm just going to subtract the 12x or 12y squared. So let me go here. 4y equals 12y squared, and I'm going to subtract 12y squared, subtract 12y squared. This actually zeroes out. So what am I left with on the right-hand side? 0, good. All right, can I subtract these? Are they like terms? The answer is no, good. Because, and honestly, does placement matter as far as like all on the left or all on the right? No, it doesn't. This has an exponent of 2, this one does not, therefore they are not like terms. I traditionally like to write things in standard form where they go from the biggest exponent to the smallest, but that's just me. And now what we're going to do is we put that in a little box, right? We got negative 12y squared plus 4y. I take my smallest number, 4. Look at my possible factors, 1 times 4 and 2 times 2. I can do 4? Awesome, let's do 4. And can I do y? To what power? To the power of 1. All right, so if I have 4y to the first power, what's going to be up here? Y'all are so good at this, good. And then what's going to be above here? Yay, plus 1. All right, so ladies and gentlemen, what we have is 4y times negative 3y plus 1 equals 0. So I'm going to have 2 different roads, right? I have one road where I set this factor equal to 0. And I have another road where I go take this factor, negative 3y plus 1, and set that equal to 0. Okay, with the one on the left, I simply divide by 4, right? And 0 divided by 4 is 0. Good. Over here, I have 2 steps. Subtract 1, additive inverse. Negative 3y equals negative 1, divide by negative 3, divide by negative 3. We get negative 1 divided by negative 3. Okay, if I want to write it in a fraction, you can always start off like this. Alpha y equals 1, you got negative 1 over negative 3, and you have 1 over 3. So you have 2 solutions, 1/3 and 0. And you could write it as a solution set with 0 and 1/3 as your answer. Okay. Any questions? All right. You know what? I'm feeling like I can knock this out. Let's look at this word problem. We have a football that's kicked into the air. The height of the football can be modeled by this equation. So we have this, where h is the height reached by the ball after x seconds. Find the values of x when h is equal to 0. So I'm going to rewrite this so that it's equal to 0. Right? I can draw my box right on top of there. Okay. And maybe I'll go ahead and move it. What do you think is going to be my multiplier? Just to give myself more space, I'm moving it down here. What's the biggest number I can divide everything by? And what about my x? 16 is both divisible by 16, and then they both have an x to the power of 1, right? Here we would have negative x, and here we would have plus 1. So we're going to go ahead, 16x times negative x plus 1 equals 0. Set each factor equal to 0. Here we divide by 16, x is equal to 0. And here, you know what, I'm actually going to do something here. I'm going to add x, additive inverse. I have 1 equals x. It's great, same as x equals 1, right? So can you tell me which one makes more sense for this problem? What is the height of the football when it is kicked into the air and it reaches the ground? How many seconds does it take to reach the ground again? 0 or 1? 1. It is 1 second. And the reason being is that when you plot this on a graph, it looks like this. The first solution is right here at 0 seconds. That's when they kick the ball. And the second is, hey, we kicked it and it took this amount of time to get back to the ground. Any questions on this? All right, we are done. If you have a question for me, stick around. Other than that, have a beautiful day.